Good afternoon, everyone. I am Gautam Manna. So, uh, this week I will be solving the assignment 2 from the last year's course. And if you have any doubts regarding the classes of second week and before that, you can ask. So, please unmute yourself and you can ask. I will discourage to comment on the chat box because for me it's really difficult to always check the chat box and reply you. Okay, let's share my screen. So, the problem 1 is you are given a position vector of a particle which is as a function of time, and you are asked to find the distance of the particle from the origin at time t is equal to 1. So, the position of the particle at time t is equal to 1 is basically, so r at t is equal to 1, which is 1 plus 1 I hat plus 1 square by root 2 j hat plus 1 cube by 3 k hat. That is 2 I hat plus 1 by root 2 j hat plus 1 by 3 k hat. So, the particle is somewhere here. So, the coordinate is 2, 1 by root 2 and 1 by 3 at time t is equal to 1. So, you are asked to find out this distance from the origin. Origin is 0, 0, 0. So, then the distance between these two points are, basically write it as d. This is root under 2 minus 0 square plus 1 by root 2 minus 0 square plus 1 by 3 minus 0 square is root under 4 plus 1 by 2 plus 1 by 9 is root under 18 by 72 plus 9 plus 2, and its value will be 80 root under 83 by 18, and if you calculate it, it will be 2.147, which is approximately 2.15. So the correct answer will be the second one, 2.15. Now in the second problem, you are asked to find out the velocity vector. So velocity is basically a vector the velocity of the particle at time t is equal to 1 and the position vector as a function of time is given. So in that case, velocity is basically rate of change of position, that means the derivative of position with respect to time. So to take the derivative, you will get ddt of 1 plus t I hat plus okay. So in the chat, someone is Gagan is saying to solve the assignment 7 and 9 of week 1. Okay, so let me solve this these questions from last year's assignment and then I will do those. So then it will be ddt of t square by root j hat plus ddt of t by 3 k hat, that is I hat. Now its derivative is plus 2 by root 2 t j hat, and which is basically root 2 j hat, root 2 t j hat plus, and this is t square k hat. So this velocity is as a function of time we are getting to derivative it. So at time t is equal to 1, the velocity will be I hat plus root 2 j hat plus k hat. Just put t is equal to 1 here. So the correct option is the first one. Now in the third problem, you are given the same position vector which is a function of time, and you are asked to find out the speed of the particle at time t is equal to 1. So speed means magnitude of velocity. So we have already calculated the velocity vector at time t is equal to 1 here, and in this problem 3 you are asked just to find out the magnitude of this vector. So the speed is magnitude of velocity vector at time t is equal to 1, which is, so magnitude of I hat plus root 2 j hat plus k hat, which is root under 1 square plus root 2 square plus 1 square, root under 1 plus 2 plus 1, which is root under 4 equals to 2. Now in the problem 4, you are given the same position vector and you are asked to find out the acceleration at time t is equal to 1. So for this position vector we have already calculated the velocity as a function of time. So velocity we have calculated as a function of time is I hat plus root 2 t j hat plus t square k hat. So this is basically dr dt. So now acceleration is the rate of change of velocity as a function of time. So then acceleration will be dv dt. Now if you take the derivative, it will be, so there is no t dependence for I hat component, so it will be 0, plus here it will be root 2 j hat, plus here it will be 2 t k hat. So we are getting the acceleration as root 2 j hat plus root 2 j hat plus 2t k hat. So now you have to find out the acceleration at t is equal to 1. So then a at t is equal to 1 is, just put t is equal to 1. So in that case root 2 j hat plus 2 k hat. So the correct option is the third one. Okay, so the problem 5, the level curve of a function at any particular level is a subset of the domain of the function. So let's take an example. Let's say function f x y is at x square plus y square. Let's call it z. Now here x belongs to the set of real number and y also belongs to the set of real number. So basically the domain is x comma y, which belongs to R2. So the domain is basically R2. The whole R2 is your domain. So now for a level curve of this function, you need to fix this z. So let's say z naught, it's a constant, and then for the equation of level curve will be z naught is equal to x square plus y square. So in that case, you are still in R2, but you are not covering the whole space. You are considering only those x and y which satisfies this equation. So basically, for this case, for this level curve, the domain is in R2, but not covering the whole R2. So it's basically a subspace of the function, of the domain of the function. So the domain of the level curve is a subspace, is a subspace or subset of the domain of the function. So the statement is true. So if you have any problem in understanding the concepts, you can comment also, because some of you guys saying that your mic is not working. So I am following the comments. So in problem 6, you are given a function f of xy, which is equals to x square minus y square, and then the graph of the graph of this function. So to draw the graph, you need 3 coordinates z. So let's call it z equal to x square minus y square. So you need 3 coordinates x, y, and z, which is in R3. That is correct, and it is such that z. So in the question, it is given z greater than equal to x square minus y square, but to draw the graph, you need z equals to x square minus y square. So in that sense, this statement is false. And problem 7. So you are given a function f of xy is equal to x square minus y square, and the level curve of f at level 4. Level 4 means, let's say f of xy equals to z equals to x square minus y square. So level 4 means this value of z is 4. That means the equation of this level curve is 4 equal to x square minus y square. And it is the equation of a hyperbola. So the second option is the correct one. This is the equation of the level curve. Now problem 8. So you are given like the limit of function f of x y when x tends to x0 and y tends to y0, it is L, and limit g of xy when x tends to x0 and y tends to y0, it is M, and then you are given a statement like limit f of x y by g of xy at x comma y xy tends to x0 y0 equals to L by M, and you are asked whether this is correct or wrong, and you are asked to find out whether this statement is correct or wrong. So let's take an example. Uh, let's take f of xy as uh, x square, let's say x square minus y square, and g of xy as x minus y. So in that case, limit x comma y tends to x0 y0. For example, x0 y0, let's assume x0 y0 is 0 point. So we are taking the limit at 0 0. So in that case, the limit will be 0, because x will also tend to 0 and y will also tend to 0, so the difference will be 0. And for the limit at 0 0, x comma y tends to 0 0, the limit of gx will also be 0, and the limit of f of xy by g of xy at when xy tends to 0 0, in that case it will be x comma y tends to 0 0, and in x square minus y square by x minus y. So it will be limit x comma y tends to 0 0 x plus y, because x square minus y square, it can be written as x plus y times x minus y, and x minus y cancels, and this limit is 0. Now this doesn't equals to the division of the limit of these individual functions, like 0 by 0 it doesn't exist, but here the limit of this fx by gx, this exists and its value is 0, so the statement is false. So in order to calculate the limit, so if you are asked to calculate the limit of the division of two functions, the ratio of two functions, so in that case the correct way to do it is as take the ratio and then calculate the limit. You cannot calculate the limit first and then take the ratio. Now the next problem, you are asked to find out the limit of this this expression. So you are asked to find out the limit of x comma y tends to 2 2 and you are given x plus y not is equal to 4, x plus y minus 4 by root under x plus y minus 2. So now this x plus y minus 4, it can be written as root under x plus y square minus 2 square, which is root under x plus y minus 2 times root under x plus y plus 2. So we have limit x comma y tending to 2 comma 2, x plus y not is equal to 4, and we have root under x plus y minus 2 times root under x plus y plus 2 divided by root under x plus y minus 2. Now x plus y not is equal to 4, it means this root under x plus y minus 2, it's not 0, so in that case we can cancel each other and we are left with limit x comma y tends to 2 comma 2 root under x plus y plus 2, which is, so if we now put this limit, it will be root under, so x tends to 2, y tends to 2 plus 2, this root 4 plus 2, this 2 plus 2 equals to 4. So the correct answer is the third one. Now the last problem, you are asked to find whether this limit exists or not. So whether this limit of x comma y tends to 0 comma 0, x square by x square minus y equal exists. If it exists, its value, whether its value is 1, 0 or 2, or it doesn't exist. Okay, so let's draw the xy coordinates. So now if you come along the x-axis, let's say you are coming along the x-axis to the point 0, 0. So in that case y equals to 0. So along x-axis, so in that case you have x tends to 0, you have already y equals to 0, so that means x square by x square, which equals to limit x tends to 0, so x square cancels and it's 1, it's basically 1. So if you come to this 0, 0 point along this x axis, its limit is 1. And now let's come to the y axis. Along y axis, so limit y tends to 0, and along y axis x is already 0. So in that case this expression will be 0 square by 0 square plus y, and which is y tends to 0. So y tends to 0, that means the denominator is not 0 and the numerator is 0. So in that case its value will be 0, so its limit is 0. That means the limit that doesn't match. I mean, if you come from the y axis to this point 0, 0, it is tending to some number, that is 1, and if you come along y axis, it is the value of this function, it is going towards a different value, which is 0. So in that case the limit doesn't exist. In order to exist the limit, from whatever direction you come, the limit, the value of this function, that must tend to a single value, but here it is not happening. In that sense, the limit doesn't exist. Okay, so if you have any problems regarding this uh, solutions I did today, you can ask me in the chat box, or you can unmute yourself and ask. And let me see the doubts you have regarding the last assignment, week 1 assignment. Question 7, question 9, and so only question 1, question 7 and question 9 from assignment 1. Okay. So question 7 is, you are given A, which is 2I hat plus j hat, B vector, which is 2I hat minus j hat plus k hat, and question C is I hat plus 2k hat. Next to find out the triple product C cross A dot B. So you can reverse this dot product, B dot C cross A. So in that case its value is, so B is 2 minus 1 1, C is I hat, so I hat component is 1, j hat component is 0, and k hat component is plus 2, and A is, I hat component is 2, j hat component is 1, and k hat is 0. Now if you calculate this determinant, it will be 2 times 0 minus 2 plus 1 times 0 minus 2 minus 4 plus 1 times 1 minus 0. So it will be minus 4 plus 1, which is minus 7. What were the options available? So it's not matching any of the options. Two minus one one. Is two one. Yeah, I think the answer provided is wrong because Gagan is saying he also got -7. So if the answer is provided wrong, then you can ask in the forum, and I think uh, they will give you the marks. Okay, so let me note that. I will talk to sir. And the next problem is so you are given three vectors, 3 points. P, which is 2 minus 2 1, Q, which is 3 minus 1 2, and R, 3 minus 1 1. So if let's say any vector D which is perpendicular to the plane, so in that case, so these two are points on the plane, so in that case D will be perpendicular to all the vectors like PQ, QR and RP, because these PQ, QR, RP, those are all on the plane. Perpendicular is D. So then PQ vector is, let's say, 3 minus 2 I hat plus minus 1 plus 2 j hat plus 2 minus 1 k hat. So it is I hat minus j hat, sorry, plus j hat plus k hat. QR vector is 3 minus 3 I hat plus minus 1 plus 1 j hat plus 1 minus 2 k hat, which is minus k hat, and RP vector is uh, 3 minus 2 I hat plus minus 1 plus 2 j hat plus 1 minus 1 k hat, which is I hat plus j hat plus 0, so it is basically I hat plus j hat. So the options that are given, okay, so this qr, that is qr is perpendicular to d and qr is k hat, qr is along k hat, so in that case d will not have any k hat component, otherwise this, so this qr dot d vector, it must be, it must be 0 because d and qr, those are perpendicular. Qr is a vector along the plane and d is perpendicular to the plane. So if qr vector, if any of qr vector has a, qr vector is k hat, so it is along the z direction. So then if d vector has any k component, in that case the dot product will not be 0. So in that case d vector, the perpendicular vector, it will not have any k component, and the option, so in that case the d vector will be, so it's, you can easily say that it is I hat minus j hat, because if it is so, then this r p dot d, it is 0, and also this pq dot d, that is also 0. That means it is perpendicular to all these three. And now you are asked to find out the unit vector perpendicular to this plane. That means you are asked to find out the unit vector along this direction, I hat minus j hat. So in that case it will be d vector by mod d, which is I hat minus j hat by root under 1 plus 1, which is 1 by root 2 I hat minus j hat. So it is in the option, I think, problem 9. Yeah, question 9. The first option will be the right one. Gagan, if you have any doubts regarding the solution, you can ask in the chat section. Okay, so some other people are asking me to solve the assignment 2. I mean, question from assignment 2, but I think assignment 2 is still due. Uh, so when the due date is over, I will solve them. If you have any doubts, then I will solve them. Yes. Yes. Hmm. Yes. Yeah. Actually, so let's say you are asked to find out limit at this point. So in that case, I mean, the theoretical definition is you are asked, you need to find the you know, surface along this point, and if all the points those are going to the same value to take the limit. See if all the points those are going to the same value, in that case you will say that the limit exists. And how to, I mean, how to choose, how to look for there are infinitely many paths, but how to look for a particular path, it is, I think, I mean, for me it is intuitive. I mean, you need to understand by looking at the problem whether there is any particular way to choose the path. I mean, if there, if along some particular path uh, the limit doesn't exist and there is a way to get the path there, I don't know. Yeah, I mean, for me, I do that way, but I mean, there maybe there is a way, but I don't know that. Okay. Hmm. Yeah, I can understand your question, but I really don't know that. So if you have some example, like whether where you are having these kind of confusions. Okay. Okay, I will look into it. Hmm. Okay. So let's say this is the tangent plane, red one, and this is the original surface. This is the f of x y. So let me check. Okay. So okay, now if you draw the tangent, so this is the tangent plane. So in that case, this uh, is del f del x. That means here we are taking y is equal to constant. So that means it is along. So let's say it is along this line, and the tangent line. So this del f del x is the slope of this tangent line. So the tangent line, it will be on this tangent plane, and for del f del y, so it's the uh, slope of this tangent line when we are considering the y, when when the x is constant. So in that case, it will be, so let's say x is constant. So these are the two lines whose slopes are this del f del x and del f del y. And now on this tangent plane, so as these two lines are there, so in that case, any point which is near the, near this, let's say you are calculating at some x0 y0, so near this x0 y0 on this tangent plane, that can be expressed as x0 y0 plus del f del x at x0 y0 times x minus x0 plus del f del y at x0 y0 at x minus at times y minus y0. Now the error that he is talking about in that class, that is, so this is the point that is on the tangent, so this is a point on the tangent plane. So now if as you are taking the limit, so you are not at this point, so you are going towards this point, so you are going towards this point along this curve. So in that case, if you look at any point on this curve which is near to this x0 y0 point, that is f of xy, that will be z plus some error. So this is the error he's talking about in this class. The error is coming because z, it is on the tangent plane, it is not on this this curve, this surface. Okay, Gagan is saying, okay, Gagan is sharing a Google Drive link and asking me to find out where we went wrong. Problem. Okay, Gagan, you, I think, okay, I am sharing my mail ID. You can mail me. Is there any other doubts? Okay, so Gagan is saying he got a minus sign. Okay, so in the problem 9 of assignment 1, the answer he got is 1 by root 2 minus I hat minus plus j hat. So this is the both are correct actually. So if, I mean, that means you are basically multiplying a minus sign with the vector. So this is basically minus d vector, and I mean if d is perpendicular to this plane, then this minus d will also be perpendicular to the plane. So the answer you got is right, but to match the option you need to multiply it with minus 1 and then choose the correct option. Okay, so any doubts regarding assignment 12, I will solve them in the next class after the due date is over, and if there is any other problem you can ask. Okay, if not, let me end this session. Yes. Hmm. Can you repeat? Hmm. Yes. So, I mean, the definition doesn't um, tell you how to calculate the V. So it just says that there exists a V for which you can do that, and the to calculate the V, I mean I think I mean in that class he already calculated the V, like you are getting a vector or the matrix that we are calling the Jacobian. So del f del x1, del f del x2, the array of that. Yes. Okay. So I mean basically you are asking the same question, like uh, yeah, I mean is there how to check all the how to check all the paths? You know, there are infinite possibilities. So yeah, I don't know that. I mean I need to check. Okay. Okay, so let me end the session.